but I think we should start with our meeting. And so thanks for introducing yourself. And I just passed the word to Lawrence. He wanted to do a review of what's been going on in FPM.
Yes, thanks, Ethan, and thanks for organising today and hosting. Some of you may know there's been quite a lot of development in FPM recently, specifically on the Fortran implementation of it. So today I just wanted to kind of give a very brief update on what those updates have been, and kind of just propose a work list to kind of focus us towards a milestone, that milestone being basically a first beta release of the Fortran FPM version. So I've got a few slides to share, if that's okay. And I promise it's only 2 slides, so it's not going to be kind of death by PowerPoint. Okay, I think you should be able to see a slide. Okay, so very briefly, to those of you who might not be familiar with the project, we have 2 implementations of FPM. FPM stands for the Fortran Package Manager. We have this so-called Bootstrap implementation, which is fairly stable actually, and it's implemented in Haskell. And this is what we're using to build the Fortran version. And then we have the Fortran version, which is aiming to reproduce all of the capabilities of the Bootstrap version, but it's written in pure Fortran plus a few calls to the system shell, which we hopefully eliminate at some point. So what we can do with Fortran is we can define a package using a package manifest in a nice TOML structure, and we can very easily build multi-file and multi-module libraries by resolving the kind of dependencies that we end up with between our modules. And we very recently got submodule support, thanks to Brad in the Bootstrap version, and we've also got submodule support in the Fortran version as well. And we can build kind of executables that depend on our libraries and tests that test the library implementation. And probably the most exciting feature for me, at least, is this ability to kind of pull dependencies from other packages and kind of link them into our kind of projects. So this is a really nice thing. So at the moment we can pull other FPM packages from Git or from our local system. And some other features that we want to implement in the Fortran version soon are kind of building static libraries, incremental rebuild, and implementing support for custom build scripts. So these are all things that are currently supported in our Bootstrap version, and we just kind of want to bring the Fortran version up to date by addressing these. So that's just a quick recap on what's going on with FPM. So today I'm proposing we kind of define a milestone, and this milestone is a first beta release. So this is going to be a development release, which is feature complete. So it's feature complete according to an agreed list of capabilities. Ideally, we can agree today, but obviously we can discuss on GitHub as well. So current works in progress. So these are PRs or other kind of work ongoing. Sebastian's opened a PR for automatic documentation using Ford. I think this is a really good idea, and hopefully it'll get merged soon, because once this is merged, we can start putting an emphasis on kind of properly documenting the internal API, and as well as adding documentation for users in a kind of easy to deploy manner. We've got PR open to add an installation script, and actually I might want to build on that and add, there's a discussion in that PR to kind of add a deployment so people can download binaries a bit easier. We've got a kind of not fair large, but a kind of medium-sized PR, which addresses a lot of command line implementation issues that are open. And hopefully we'll get a third review on that and merge it soon. I'm currently working on implementing the incremental rebuild capability in the Fortran version. And finally, I've just added in the SDD-lib OS kind of sub-project, which Arjen and Martin are working on. And that's going to kind of get rid of a lot of the system calls that we're relying on in FPM at the moment. So that's kind of on long-term ongoing work. So in addition to incremental rebuilds, the two additional things to match the Bootstrap version are building static archives. This isn't a very difficult thing to do. It just requires a bit of knowledge of the current backend. And implementing custom build scripts. I think this is quite important because it allows us to extend FPM to kind of more complicated packages. So the only other things I want to propose that we add to the kind of list of the to-do list for this milestone is supporting compile and link flags, so users can kind of customize these link flags. And this capability is actually mentioned in a number of issues, which I've just written here. And I think this is quite an important capability to really build in soon. There's an issue here for an install command. I don't see this as being particularly complicated to implement. And initially it can just be for executables. So I think that would be a fairly small additional feature to add. And finally, kind of error and warning messages for users. There are two issues that discuss this, but essentially this surrounds kind of various module naming conventions that may or may not exist. So for example, it's been decided, I believe, that we should be enforcing or either enforcing or warning if a module does not start with the package name, and this is to kind of implement a pseudo namespace to avoid packages basically colliding with each other in terms of module names. So this is kind of the work list that I want to propose for the milestone, and I guess today I'm just asking whether there's any objections to what I've put on the list, or whether I've kind of missed anything out that someone would very much like to see in a beta release of the Fortran version. And then after our discussion today, I'll go through the issues on GitHub and basically all link them to the milestone so that we're all on the same page and we're kind of a bit more focused on what we should be addressing on GitHub, if that makes sense. So thank you for letting me speak.
Well, thank you. This looks awesome. Actually, I'm super excited about this. I guess I will have one question. Will this, if we implement all the lists, all this that's on your list currently, will it allow to build FPM itself or not yet?
That's a good question. I guess you might have missed it, but I believe FPM can build itself now, actually. I put in a PR a couple of weeks ago that got merged last week. I think that pulls, so Fortran FPM can pull Git dependencies. And that was the last thing we needed to build FPM itself. So Fortran FPM, I believe, can build itself. Yeah.
Okay, so in that case, what I would recommend is kind of switch, like as we release this beta, kind of switch to the Fortran FPM and provide some bootstrapping options for users. There's a couple of ways to do.
Yeah. So on that, so that's a good point. So this is kind of the idea of the beta milestone, is that the Fortran version becomes the version that's recommended to users. And in terms of bootstrapping, I briefly mentioned it, but I have on my own fork and the ability to basically upload development releases as they are merged into master as executables. And I would probably recommend that as the easiest way of delivering it to users. Obviously, we can only support architectures that are basically in GitHub Actions, but that does cover x86, 64, Windows, Mac OS, and Linux. So.
Exactly, yeah. So I was going to suggest to maybe, if that's the case, to set up our CI to officially upload the binaries on all three platforms for every master. So that would be like the latest master. We have to, figure out how to, where to upload and so on, but that can be done. And then we should start making releases by, and I'm proposing to do it by tagging the master, and the CI will automatically upload released binaries. Again, at some website, and that way, so for bootstrapping, let's say for me, I think I'll just download the binary for Linux in my case, and then just build the FPM from source using that binary, and I'm done.
Yes, yes, exactly. Yeah, that is exactly what I'm planning. And in my fork, I have a CI set up to basically deploy GitHub releases as you suggested. So I want to open a PR for that. So I'll add that to the milestone list. Yeah.
And are you thinking of uploading just when you tag the master, or for every commit?
I was going to do it for every commit and mark it as a latest. Basically, it's not a stable release; it's a latest release.
So how do you do it with the GitHub releases? Like,
so there's basically a GitHub Actions that you can include into your workflow file that allows you to it interfaces with the GitHub CLI and API, sorry, and it allows you to upload a release.
is it like so essentially on the FPM GitHub there'll be a release for every commit?
No, it will be at the moment on my fork. The way it works is it basically overwrites a fixed release every time you push to master. So yeah,
I think, yeah, okay. I think that's fine, because the way I'm imagining that, the latest will be used if we fix a bug, let's say, and somebody needs to kind of use it right away.
Yes, exactly. Yeah. So
yeah.
Yeah. So we're not promising any stability with that binary release. It's just the latest trunk. Yeah.
Okay, I think that's perfect. So I'll help you. Just once you are ready, I'm happy to help test it.
Yes. Thanks a lot.
And these will be binary releases, right?
Yes, the releases that will be uploaded will be binary. Yeah.
Great. What was I gonna say? I forgot. So I have, regarding your list, I'm also very happy with it. I would even say maybe there's few items that are not necessary for beta release, in my opinion. For example, install command, maybe we can do that later. Warning messages, we can do that later. But this looks great. I do want to ask you about PR 206 by Damien Rousseau with the installation script. So can that be merged, or is that in some kind of development or progress? It's unclear to me from the thread.
I think I'll have to check again, but I think my impression was that it was, I think Damien was happy with it and wasn't going to add anything else to it. And that was my impression when I last checked, and hence I gave it an approval. I'm not sure if anyone asked for any changes or not.
Okay, we can revisit that.
Yeah. As far as I'm concerned, I would be happy to merge that as is.
Great.
Thanks for the feedback.
One more question. The thing that I forgot. Do we at this point start doing some kind of semantic versioning or some other kind of versioning also?
Yeah, that's a good question, actually. I wasn't planning on doing that because we don't, I don't really want to make any promises about stability. And it frees us up a little bit if we don't do that yet. But,
well, why do you think it makes a promise about stability?
Well, I guess it doesn't make a promise about stability, but we have to start keeping track of breaking changes, don't we?
Yeah. The issue with the semantic versioning is that every time you make a breaking change, you're supposed to increase the major version. But what I ended up with Fortran is that until I reach version 1.0, in other words, right now the version is like 0.9, I simply increase the second number, so 0.9, 0.10, 0.11, and it doesn't matter if I break something, I just keep increasing it. And then the patch version I only increase if I do backwards, if in the semantic versioning, the patch version you increase if you don't change any API. So I follow that, but then the second number I increase every time I make a release, and I don't care if I break things, because until I reach version 1.0, it can break things. And I think we can do something similar for FPM.
Okay, yeah. I don't
That's
have
how I've been using it too.
Okay, yeah, that sounds good. Yeah.
Will you, Lawrence, will you make like a pinned issue for like a beta release milestone, or is it already in the pin that?
I believe there's a roadmap issue, so I was going to kind of edit that and build on top of that.
Okay.
Yeah.
Maybe you can attach your slides as a document.
Yeah, that's a good idea. I'll share these slides just for yeah, so everyone's got them.
Cool.
Do you plan to have a website like there's one for stdblib?
Yes, so I think the stdlib website is deployed from Ford. Is that right?
Yeah, indeed. Yes. Yeah.
Yeah. So that's hopefully what we'll do with PR209. We'll deploy it to the Fortran Lang domain.
Yeah. Good.
Okay,
So,
if there aren't any questions, I'll stop sharing. Thank you very much, everyone.
Thank you.
Lawrence.
So the next topic we had on our agenda, Jeremy wanted to review the pull requests in stdlib.
Yeah, it was not. It was just to mention that there are two main PR in for stdblib, and I try to review both of them. But it would be good if someone also could check and review carefully these two PR. Try to merge them if possible.
I started doing a review of the bit set, but it's just a huge like a huge pull request. It's I think more than 5,000 lines.
Yeah, indeed. And the other one is also really huge. So I started, but yeah, I need to find time for that also. So yeah, maybe next time it would be good to have smaller pull requests to facilitate the reviews. But
does Andre, do you maybe have some experience from like from SimEngine? Do you set up some kind of like limits on what is the size of a pull request to make it accessible for reviewers, or?
Like when it's ready for review?
I mean, simply like on the size of changes. So if it's something like that, I need actually a whole day to work through the code, or is it more encouraged that people like make small
Yes.
pull requests?
Yes. I think, yeah, what I always, from SimPy and SimEngine and every other project, I always recommend people to submit as small change as possible, and also kind of semantically kind of just concentrate on just one thing in the pull request, and don't mix other things that you discover. Typically when you create something, you discover, oh, I want to fix this and this and that. I always tell people, submit separate pull requests and just, you know, isolate the feature and only do that. And that makes it very easy for reviewers. You can just, you know, the pull request is doing just one thing and you can concentrate on that. Sometimes it's not possible, you know, if it's a huge change and it's just, you know, then we just have to do, you know, what we have to do. But in general, yes, small pull requests.
Yeah, so maybe we should edit the like guidelines for developers.
Yeah, which pull request do you have in mind? What number?
Just a second.
240 and
can you post a link to the chat?
Oh yeah. Good.
239.
Yeah, there are two of them. They are pretty big. And then, yeah.
Thank you.
So the one of the byte set, I review it quite carefully. And Diff, yeah, 240 I started, but yeah, it was I didn't get time to do it carefully. So
yeah, so this pull request is tough. You know, it's hard to make it smaller, I think, because it's kind of the initial implementation of the distributions. So that we just have to kind of do our best.
Same
think,
with bit sets.
Yeah. So is there like a disagreement, like a fundamental disagreement, or is everybody kind of on board of getting this in general? It's just about, you know, getting the little things correct.
based on discussion, I think there is an agreement to get both in a STDB lib. Just need to review it to be sure that.
Yeah, they just need more reviewers.
Yeah, I think it's a combination of big PRs and not too many excited people about them. It was similar with a logger. It took a long time.
So when it comes, okay, so let's kind of, you know, when it comes to the distributions and statistical functions, it seems to me that we all agree it's part of the stdlib scope. Am I right?
Yes.
Yes, I would say so.
So if that's the agreement, then at that point, I can also try to help review it, and Milan can help it. Kind of have to do our best to kind of get it in some form that we are okay with, and then we'll just keep improving it with future pull requests. That's what I would recommend.
Yeah. That was my point.
Okay, thanks, Jeremy. Are there any other questions about stdlib or?
Yeah, so with the distributions, so the 240 I think is clear. It just has to go in. The 239, the bit sets. Is there an agreement that this belongs to stdlib or maybe not?
I think in the issue where it was open, there was agreement that it's a handy feature. So it's used in a ton of applications, but it's about, let's say, nailing the API. So I started making some small examples, some usage examples, but just managed to finish one. And there, let's say, the Fortran bitsets kind of competed well with C++. So to analyze 10 million, so to find the number, to count how many different numbers in a set of 10 million integers, C++ needed 4 seconds and Fortran bitsets needed 8. So I was quite impressed.
Can you post your example somewhere?
Yeah, essentially I have like just a dump of resources on bitsets. I've put it in the chat.
Yeah, post it on the issue or post it somewhere where people can comment and look into it.
But I'll continue when I have more time.
Okay, yeah, so I think we just have to also review that 239. I'll try to get to it in a week or so also. And then last thing for stdlib is one thing I was going to propose is the Fortran 20x approved a split function for strings, and I think we should have an implementation of it in stdlib because it's coming into the standard. So we might as well have it there, and once it becomes part of the standard, we can probably remove it. But the reason to have it there is that I noticed it got approved and then it got changed. In other words, a proposal got approved for inclusion to the standard, and then people realized, oh, we made a mistake. This shouldn't have been this way, and so they provided it like a change. And so it seems to me it's a prime candidate for implementation in stdlib, so that we can play with that and use it and see if the API is the way we like. And if it's not, we should create a proposal for the committee to change it again if needed.
Do you have maybe a link to the paper from the standard?
Yeah,
I can open an issue if you want.
Yeah. Yeah, go ahead with the next topic, but in the meantime I'll find the link.
Yeah. So the remaining topics are maybe less about development, but more kind of broad. So auto diff. There was a nice discussion on Fortran discourse. Hopefully, I can't remember who posted the question anymore.
I'll put a link at the bottom of the issue, of the discourse issue, the talk issue.
So I think we wanted to kind of brainstorm on how we could make automatic differentiation more accessible in Fortran, because obviously there's a lot of implementations for the forward mode, and there's at least one good implementation of a reverse mode in Tapenade. But I think these tools are still quite exotic for most Fortran users. I don't know if you'd agree.
Yeah, so can you summarize just kind of quickly, is the idea that it differentiates differentiates the code essentially, right? But can you summarize it to the forward and backwards modes just quickly?
So I don't really have a perfect understanding myself, but so when you do the forward mode, you just need to overload the operators for plus minus products division, and then essentially you kind of use the chain rule from calculus to differentiate your function. On the other hand, in the reverse mode, you need to construct a graph of the operation and then somehow do a backwards pass to figure out how to propagate the sensitivities.
Yeah, so the forward mode, you propagate sensitivities or kind of deltas on your inputs to get the sensitivities of the outputs, whereas in the backwards mode, you propagate deltas of your outputs to get sensitivities of your inputs. So mathematically, if you linearize your function and you get Jacobian, then the forward mode is a Jacobian vector product, and the backwards mode is an adjoint vector product, so it's the transpose of your Jacobian. And like Ivan said, the backwards mode is really quite significantly more complicated from a computer science point, because you've got to reverse your computational graph so that you can basically do everything in reverse. Yeah, the more you read about it, the more you get confused yourself. It's bizarre. It's amazing that people have been able to do it.
Okay, yeah. So it looks like, and can you summarize the approaches that the tools take to implement this?
Yeah, so the two main approaches are object orientated, where you just overload your operations. That's quite simple for the forward mode because you just add an extra operation for the chain rule. You can do it in the backwards mode, where you build you have to build a graph of operations that you then consume again in the backwards. It's very, very slow because you're doing everything at runtime. So the second way of doing things is by source code transformation. So this is where you pass your source code and you generate new code to either perform the forward or the reverse pass. And this is generally the fastest way because you can exploit compiler optimization. So that's what the Tapenade tool does. But obviously, it's a lot more difficult to implement the source code transformation approach.
Okay, yeah. So for Fortran, what I've been planning for a year at this point, people have been asking about this all the time, and it seems the most natural way is the compiler simply, when it has it transforms the source code to AST, abstract syntax tree, then it figures out all the semantics, so it transforms it to ASR, abstract semantic representation, and that representation is very easy. I can create, if people are interested in testing this out, I can create a prototype which will differentiate the code kind of at this level, and you can think of it as spitting out a new Fortran code with the derivatives. And the forward mode is easy to implement. I can see that in my head how this would work. The backward mode I have to study. I don't know exactly the details, but it seems to me both can be done.
Yeah, absolutely. I think you're completely right, because basically all of these tools, they already have to do that anyway. So you've already got the ASR, so you may as well start from that. And yeah, I think that's a good idea.
The only other way this can be done is, so there is this, one can do it at the LLVM level. There are, I think, some tools that allow you to differentiate at the LLVM level. But in Fortran, we might as well do it at the higher level, the Fortran level. And the advantage of that is that it can spit out Fortran code for you to see, is this what I like?
Yeah.
Kind of under the hood. And in fact, the tool can be used to just generate, I don't know, that was my question for David, I guess. How, as from a user perspective, when you want to use a tool like this, do you want it to generate Fortran code that you kind of, and then you just compile it yourself, you know, with the derivatives, or not?
So
yeah.
Sorry, is David here? I'll let you speak.
Yeah, so what I did at the beginning, when I start to use automatic differentiation, I didn't know there was some tools which exist. So I just make my own things. And it starts almost 20 years ago. So, but recently I made a library, but it's just forward mode. So it's just overloading operators. So it, in a way, it's quite simple. So that's the only thing I know, and it's quite efficient in a way as well. It's very simple to do it. It's like the one in the NAC Fortran in the NAC Fortran library. They got the similar trick, I think.
So if, let's say, we implement this as in Fortran as a code transformation, how would you like to use it, if at all?
Sorry, David, you can.
Yeah, sorry. I'm not sure I will be able to use it, because the thing I need is not, usually I'm not doing a Fortran implementation of, let's say, a function. It's defined as an input in my data file. And then, so there's no Fortran, let's say, subroutine doing with some kind of a function. It's just the input which give me the, let's say, one function, then some kind of link transformation between between function. Like, and in this case, I'm just using chain rules. So I don't have, except in some particular case, I don't have any given function. So I cannot use directly that. I mean, in my case.
Essentially what you are saying, you only have the expression at runtime that you want.
Exactly. Yeah, somehow, yes.
So the kind of confusing thing about this automatic differentiation is that you don't actually get the expression, but you just get the value, the numerical value of the derivative.
That's working very nice. I mean, it's.
Yeah, I think what you're asking, Andre, is though what it would look like for a user to do it using L Fortran. And for me, I would like to see the Fortran code that it spits out. I would like to see a new function that has a similar kind of signature, which I can use to propagate forward or backwards. And the reason I would like this is because you can write these tools as well as you like, but the quality of the code that comes out is always some kind of function of the quality of the code you put in. And especially with the backwards mode, you can end up with a lot of redundant data storing if you write your code in a certain way. And what I learned is you have to rewrite your code going into the function to kind of make the derivative code more efficient that comes out of the source code transformation. So as a user, I would quite like to see a kind of a new Fortran function spit out.
And do you have, for your applications, all right, do you have some simpler functions that I could try, or is it always very complicated, a lot of kind of big code?
Yeah, I could probably put together some simple functions, definitely. Yeah, it always consists of smaller functions anyway. So.
Okay, so in that case, I'm going to kind of create a prototype that would just do this, and it would work initially with simpler functions. Down the road, it would work with any Fortran code, I think, but initially very small functions. That way you can or you and others can start playing with that, and we can kind of brainstorm further. And it's obvious. So it looks to me from what David said is that this would only work if you actually have Fortran code to differentiate. If you only know the expression at runtime, it seems to me it's almost like symbolic manipulation libraries that I've also written, but that's a little bit different, it seems to me. Or I still
Yeah, no, that's completely right. You have to have it at compile time. Yeah, yeah. Otherwise, it's symbolic. Yeah. Yeah, that sounds really great, Andre. I'd be really excited to try
okay,
that.
I'm gonna do that. Thank you.
So, something I wanted to suggest concerning this AutoDiff is maybe to create like a small page on Fortran Lang. I posted a link of what Julia has. So if you Google Julia AutoDiff, the first thing that pops up is this single page that directs you to Julia packages. And I think maybe now that Fortran Lang is on Wikipedia and rising up in the Google ranks, maybe this way also we get like some more users to find out about AutoDiff.
Yeah, I think that's a good idea. And actually, I'd probably be quite tempted to write a mini book on using some of the libraries and tools that are out there, actually.
Yes. This would be helpful because people keep asking about this all the time, and we can then have a page and the page would just summarize, all the libraries, all the tools that are out there, and the state of the art for Fortran.
Yeah, I'd be happy also to contribute. So I've used this DNAD library, and that was actually quite simple to set up.
And recall that our website also allows for just one-off blog posts or articles that, if something doesn't necessarily fit a minute book format, but you still like to write it, you can for sure.
Yeah, this seems to be more than a blog post. I think we want to keep updating this with as we progress with our tools.
Yeah, so I think we've made some nice conclusions about AutoDiff, and we can move on to the remaining topics. Andre, would you like to first talk about the goal of Fortran, or should we do now your demonstration?
I'll do the goal of Fortran. Let's keep it kind of short, since unfortunately the participants from the thread are not here. I'm going to share my screen so you can see what I'm talking about. I'll do share my screen. Let me know once you can see it.
Yes.
Yes. When I click, yeah. So I'm going to click on this. There it is. Oh, so I found this very nice, actually, article about high performance Fortran. If you haven't seen it, if you go to this course, you can find this high performance Fortran thread. When you click on that, it's a Hacker News section, so you can kind of read what people are writing. For example, they say, I like Fortran, but the productivity boost of REPL, which means kind of the interactive, like Python, read about print loop. That's what is awesome, and that's why I use Julia. So that's, I'm hoping to fix that with Fortran. So when you click on the first thing, it goes to an article that kind of documents history of the high performance Fortran. It's kind of a long article, has examples and so on. It's interesting, and I think there's all kinds of lessons that what we can learn from it. And so I kind of asked the question here, and then long thread, and essentially it kind of. Steve is the convener of the WG5, which is the International Fortran Standards Committee. And essentially, he was asking, so I was mentioning that Fortran should improve some of the things, how to run on the GPU. And Steve was asking if I can provide some specifics. And my answer was that we kind of have to work on it to kind of find exactly what's broken. But the fact seems to be, at least from all the codes around me, is that people are struggling with using Fortran to run on GPUs from all vendors. And then the discussion further evolved into kind of discussing what exactly is the goal of Fortran. And so unfortunately, I think Milan and I are, I think, the only participants. So I'll just kind of summarize what was discussed. It seems to me that most people agree that Fortran has kind of a niche, which is the scientific computing, and so we should do our best to remain number one. Or in fact, I would even argue we are not the number one anymore, but we should reclaim the number one post for place for scientific computing. I think Fortran should become the number one, so that should be our goal. And then Fortran is also a general purpose language. So the question is, how good do we want to make Fortran for other tasks? And the answer is, I think, well, as good as we can, but we should not do it. We should only do it, while keeping number one for scientific computing. And so we were discussing, you can kind of read the arguments, kind of Fortran fan was suggesting that there are a lot of things missing in Fortran if you want to do anything beyond just array manipulation, like string handling, for example, could be vastly improved and so on. And Steve was saying we should kind of stick to scientific computing and so on and so forth. Milan, and I will mention actually Peter Klossler had a very good point, and I agree with that. As you can see, I added a star or whatever, heart. Essentially, he's saying that we should kind of stick to, or like ensure that we have a good story for high performance computing, and he mentioned some of the things that are kind of preventing us or kind of that we should improve to get there. And I agree with that. Anyway, Milan, do you have any comments?
No, good summary. I mean, overall, I like with your proposed quote-unquote plan that this should be tackled through compilers, compiler extensions, pragmas, things like that, to experiment, get things working on hardware without necessarily baking these things into the language specification.
Good point.
Yeah, I mean that's all I have to say. Yeah.
Well,
I pretty much agree with like everybody here, and there are multiple views on the problem. And I wrote to you in an email on this conundrum between whether to develop Fortran so it's more apt as a general purpose programming language and bring it on a more equal grounds to other popular languages, or to really double down on what Fortran has been great for, which is number crunching over arrays, which to me seems to be Steve's philosophy. And I don't know what's the answer. I mean, I think both need to be advanced and pushed forward. Getting Fortran improved in terms of general purpose computing would probably help also with its niche of scientific computing, simply by providing better facilities, better tooling, all that. And only one part of it is by improving the language. A lot we can accomplish by developing the tools and libraries.
Yeah, exactly. Yeah, I agree. Since we are at this, anybody else has an opinion on this?
I had some thoughts, maybe not so much about the Fortran standard per se, but more about the tooling. So I think Milan had in his FortranCon talk something about how essentially, because Fortran evolved in this pre-internet era, it was quite hard to, let's say, disseminate code and share. And now we just have like this netlib dinosaur, and like all the good code, or what I imagine is good code, is in some kind of proprietary libraries like NAG and IMSL and Harwell library. And then I guess a lot of companies maybe have their own. And somehow the open source community is stuck without any really Fortran tooling. And so I'm not sure if maybe I just see it this way.
I think we all see it this way.
Because in C++ they have Boost, which is really like a high quality community developed library, which includes also tools for numerical stuff and containers, and it just makes programming a bit easier.
Yeah, I think what you did is essentially the motivation for stdlib and FPM.
I had a thought on this high performance stuff, that it's kind of a goal that is in tension with itself, right? Because the goal of the Fortran standard and high level languages in general is to be able to write portable code. But if you're trying to leverage specific hardware, you are targeting a specific hardware and therefore not writing portable code. So supporting this like multiple GPUs really is a very tense, almost in conflict of trying to get the Fortran standard or its, you know, tools and portable code to support, you know, being highly performant on specific hardware is kind of in tension. So it's a really hard problem, which is, I think, is why it's not been really well solved yet.
Yes, so I agree with that. Actually, 100%. It's a very tough problem, precisely for the reason you said, but we have to work on it. And I think what can be achieved almost for sure is very good performance by default on all hardware. In fact, Fortran, in some sense, that's the original mission of Fortran. It was to write high-level code that runs on the latest machines. Back then and today, the latest machines, they have GPUs, and so you have to be able to use them. And you're right that, and that's been, I think, always the story with Fortran. If you write code in Fortran, yes, you can kind of, you know, arrange your code a little bit differently and how you do the arrays and so on and so forth. But if you live on the absolute best performance, you might need to, you know, an example is just matrix vector multiplication. Well, you can write it in Fortran and you'll get a good performance, but if you want the absolute best from the hardware, you have to do it in assembly, you know, in OpenBlast, for example, or MKL. So, but the point is that by default, you should get very good performance, and you do. And in the same way, you can get very, I would say, high percentage of the theoretical peak from GPUs. You should be able to get it from Fortran. And if you want to get to 100%, you might need to use other tools. But Fortran should get you very far. I think that should be the goal.
Any other thoughts on this issue? It would be nice also if we could hear like an industry perspective. I don't know if any of us here represents that community. If not, we can continue in the discourse thread, and 5 minutes remain for Andrei's demonstration.
Sorry. So for that, I just wanted to show you, for the last meeting of the Fortran Standards Committee, I prototyped and I should start with the link to the proposal first. One of the proposal that's being considered for 20X. So the next Fortran standard is called Conditional Expressions, and we have an issue open for it. You can read the proposals. Go to the top so you can see it. You can see the proposals, you know, read it. There's many, the syntax is not set yet. There is a lot of arguing about it. What should, you know, essentially the idea is replacing kind of if, you know, nested if statements with essentially just a single line expression, conditional expression. So if something, then D, something else, then epsilon X, for example, and that will be the result of the expression. So I implemented that in Fortran, and I just wanted to show you that. find it here. So it's in the notebook. And so this was one of the syntax that was proposed. So for the idea is that each branch of the nested expression or conditional expression has to give you the same type. So in this case, it has to be both integer. And if it's not the type, you get an error. And then it's an expression, so you can use it in an expression, you know, like that. So if false, then 10. So in this case, it should be 20, and then you add 50, so the result is 70. And then you can also assign it to a variable and print the variable. You know, this can be also, this is an expression, so it can be if I is equal 70, then, you know, make it something, you know, or if I do not equal. So what's interesting about this is that it allows you to play with the feature and kind of get an idea if you really like it. And I'll be honest, I don't like this at all. The syntax seems terrible, but this is just one of the many syntaxes, you know, people propose other ideas. And so it's just kind of cool to be able to play with that. So I just wanted to share it and encourage more vendors to do the same with other proposals. And in terms of, it took me about 1 hour to do this, so it's very simple. And so I want to do this for more examples also. And you know, I can show you the pull request. It's just really just a few changes really. You know, you can see I just kind of add some node, you know, and those are all tests that are generated. You know, I just kind of add a, you know, it's like one function, you know, I just kind of do some stuff here, and the parser, you know, has this, and that's pretty much it. So it took me about 1 hour. It's not, you know, and some test. It's obviously it's not, it doesn't cover all the corner cases. You know, for that I would need to spend more time on it. But to just get something, you know, that allows one to, you know, to play with that, you know, interactively, for example, or even just compile it to machine code. It's just very nice. And so I would like, you know, for every proposal, I would like there to be an implementation like this so that people can actually play with that.
Andre, just a comment on syntax. I see that you use end-if as in like closing an if block. I wonder if, considering this is an expression and not a construct or a block, whether you really need end-if. So if you dropped end-if, syntax would improve. It will be shorter.
Yeah,
so kind of like what Python is doing, but Python is already not closing blocks using end statements. But end-if is probably not necessary for parsing here.
Maybe, yeah, I would need to, I would need to play with that.
Especially in that case he just looked at, how would you know whether the else branch is 20 or 20 plus 50? Because you have to figure out where that expression is. So you either need the whole expression.
In that case, maybe parens.
You either need the whole expression in parens, or you need some sort of end signifier.
It's tough. So this is one of the features that looked great on paper, and then once you actually see it, and especially once you implement it and play with that, I'm not sure I like it very much. But you know, people can make their own opinions, and having this implemented, I think, helps.
Seeing that syntax work, I actually love it. But
all right, well, there you go.
It's it's highly subjective.
Would it be possible to use this in I forgot what they are called in Fortran, but kind of similar to list comprehensions in Python? So, for example, if I just want to like make a vector and have half of the elements one value, half the other, and I kind of use an if to iterate through one vector and create a new one. Would this work inside?
Yeah. So.
Yeah, I think something like what you wrote.
Yeah, something like this.
Implied loops in the array constructor syntax in Fortran almost give you full list comprehension.
I think the answer is yes, because
might get you a lot closer.
I think the answer is yes. So semantically, this is just an expression, and I think in the initializer for arrays, that's already in Fortran. You can use any expression, so this should work. I don't have it. I don't know if I have it implemented, and I don't remember the syntax, but it should work. Yeah, I don't think I have the. I don't know if I have the array. Yeah, I don't think I have it implemented yet. The array initializer, but yes, I think it should just work.
The loop counter declaration goes at the end of the implied do, but
oh, is it the expression first?
yes, yeah. The I equals 1 to 10 goes at the end.
Oh yeah.
Version.
See, I'm struggling with the. Oh, I see, and it's like.
But you can plug
it like that.
Yeah.
And I think you need one more bracket.
And yeah, this might be. Oh, okay. And then I have to put the end if because I only implement the. And I think I don't have it implement. I think Fortran doesn't. I can't remember right now. I know. Or maybe it's like I can't remember the syntax, but anyway, don't want to waste your time. But yes, after I fix these little things, that should work.
Because that I think that wouldn't be that bad as a.
Yeah, that's a good point. That actually is a good point. That's a good use case, actually.
Mm-hmm.
Thanks.
I think we should add the use cases at least somewhere.
Yes, I'll put this use case into the issue.
Yeah, thanks, Andre, for the demonstration.
Thank
so,
you.
if anyone would like to discuss any other business, feel free. If not, thanks for joining and see you next month.
Thank you all.
Thanks very much.
Thanks, guys.
Thank you.
Thank you.